Hello learners, welcome to another session of geography, and I hope you're ready for it. It's geomorphology. Some of you don't like it, but it's a section where you can score a lot of marks. But let's not waste time. Let's get on with it. All right? So let's look at what's the main things in geomorphology again. All right? Very quickly, you're going to look at all the concepts related to a drainage basin. Know those concepts. Otherwise, you won't be able to apply them. Then you're going to look at various other issues on fluvial, river profile, river grading, river rejuvenation. All right, these things are simple. Identify and describe fluvial landforms, river capture, superimposed and antecedent streams, and catchment and river management. Looks new, but it has been there before. We have covered it before, but I'm sure you know all this work now. All right. So let's get down to the questions. That's the most exciting thing. Okay? And again, as I always say, please learners, do not look at the questions yet. Look at the resource. I know you get fed up of me saying that. All right, let's look at what this resource gives us here. Okay, it gives us a little profile looking at the river. So I can see number one, precipitation. Okay, I can see here the rainfall. I can see this is a high-lying region, so that is my source. Then what is saying A, B, C, D? I can see this is showing me the upper course of the river, the upper course. Here, very quickly I can see what's happening. Flowing quite straight here. Steep gradient. Can you see I'm building it up? If I know my information, I'm relating it to here. Then I'm noticing what's happening down here. All right? I'm noticing as it's moving, it's starting to wind. Not so heavily, but it's starting to wind. It's starting to meander. So B could be my middle course of the river. Here I'm noticing a massive winding, and the gradient is quite flat here. It's flat. So what am I looking at here? My lower course, the flat plain, the braided streams, the sand islands forming in there. So I've picked up quite a bit down here. Obviously, there's a few more things. This is my watershed. You know, it's a high-lying area separating two streams. Okay. Not much else is pointed, but I'll be able to determine like my interfluve, my confluence. I'm not going to worry so much because the examiner has highlighted certain issues down here. Let me look at what else has been given. What is that? D. I could see sand islands. I could see streams flowing in between the sand islands, and obviously they're going to join again. And they're coming in here. So that I immediately pick up is my braided streams. Braided streams. Can you see? Geography keeps up with style. Even geography has braids, like you guys out there. Okay, so I've got quite a few. Where does this fit in, the braided streams? I picked up already. My braided streams fit in the lower course. Okay, because there's a lot of deposition. Okay, let's look at the questions now. Identify stage A, B, and C. Learners, you don't even have to look anymore. You know the answers already because you interpreted the diagram. And you know A, lower, B, middle, C, A, higher. I'm getting a bit old here. Or upper, B, middle, C, lower. I've identified the things already. Can you see it? Each one mark each. Upper, middle, lower. Just one little warning, learners. Some of you get too trigger or pen happy and you just write upper, middle, lower. Please, one important thing, and learners lose marks, please write the letter next to the course of the river, and that will give you your 3 marks. Okay, let's go on. Draw a rough cross section for each of the stages. Again, can you see that scaffolding, learners? what actually happens here is, if you don't interpret the first question, you're going to mess up the other questions. Now, you've already learned very quickly, upper course, vertical erosion. It's starting to form the river, isn't it? So here, in the upper course, steep-sided valleys, narrow, because it's starting to form. What happens in the middle course? It's now we have vertical still dominating, but we also have lateral. So here it was one. Here we have this happening, vertical and lateral, because it's carrying its load, it's bumping, the material is there. So what's happening? Maybe I should draw this a little wider. Eh? Maybe I could draw it like that. The river is getting wider. And now here what happens? Carrying a huge load. All right. But it's flat, less erosion, okay, more deposition. So what happens in this one? The valley becomes wide because we basically have some lateral erosion and more deposition. So we worked that out, learners. We knew it already, and I know at home you're saying, Dave, you're boring me. I know these answers already. All right? There we have it, A, B, C. All right, getting wider and wider. Identify feature D. We've already identified it. We know it's a braided stream. We're too good for this paper. All right, so let's go through it. Now I need to press my pen again, and I'm going to get it. I am going to get it. It's not working. Yes, we have it. It's a braided stream, and you've got your 1 mark already. All right, braided stream. Can you see it? Learners, something very important. If you can take the diagram and work out the questions, 70% of your battle is won because you already know the answers. You actually save time. All right. At which stage is feature 1? You already know it. It's at which stage is feature D and not 1D found? You know already. It's in the lower course. All right. And there you get your 1 mark already. Lower course. You've already worked most of your answers. Give a reason, scaffolding again, to take that lower course, and now we add further. Give reasons for this. Why is it in the lower course? You know already. For braided streams form sand islands, and for sand islands to occur, deposition has to happen, so that then the rivers have to cut between the sand islands. Only if deposition happens, sand islands form. So therefore it's in the lower course. And let's look at our answer there. All right, there's a large amount of deposition which forms the sand islands for the streams to cut through, creating the braids. Okay, go to any geography teacher if you want your braids done. We'll organize for you. We know about braids. All right, explain the formation of feature D. Related, we can take question C and actually put it into question D. Okay, let's look at the answer. You know already, all right, that the river occurs, the gradient is gentle, okay, becomes gentle. Please, a full explanation, because it loses its energy, all right, and as it loses energy, it deposits and forms sand islands, which rises above the level of the water. Okay, now the river has to cut through the sand islands, and it creates many small river channels. All right, river channels, which recombine after it passes the sand island. Once it passes all the little sand islands, or it goes around, and then it comes into one stream again. But the braids is that pattern there. Any 2 points on the explanation would give you your 4 marks. Okay, again, learners, anything difficult? No, it's just practice and interpret. Okay, I'm going to go to the next question. Let's look at this one. All right, refer to figure 2, which contains information about the fluvial processes, and answer the questions that follow. Let's see what it has here. Number 1, it shows us the river, which is meandering. It shows us quite flat surfaces on both. So this could be your lower stage, if you look at it here. All right, because there's a floodplain. The river has got quite a few meanders on it. Okay, so it's your lower stage. Let's see what else it gave us, learners. It talks about average stream flow. It seems to be that there's water there all the time in the river, which is quite strong for the average stream flow. Then, let's look here. It gives us summer flow. And what do we notice about the summer flow? There's a lot of water. So this area receives its water mostly due or rainfall or precipitation mostly during summer. We already interpret that by looking at these little things and also looking at this, all right, compared to this. Can you see there's a larger amount of water here compared to there in terms of the average? I could also change this. I changed this a bit. I could make this winter if I wanted to, if you want to do further exercises on it. All right, but we're taking it as the average flow. Is there anything else on my diagram? Nothing. Okay, now the first question, which is related to the diagrams again, name the profile of the river shown in the sketches. You know you've done two profiles. You've done the longitudinal profile and the cross or transverse profile. Here we can see clearly it's cut through to show us the width, etc. It's cut through. It's not giving us this, which is the longitudinal. It's giving us the view where it's cut across the river and it shows you from side to side, which is definitely your cross or transverse profile. So let's look at it. Cross or transverse. Both mean the same thing, which will give you your mark for that. All right, so the examiner is slowly getting you into the questions, leading you on. Let's look at the next question. Is this river perennial or seasonal? I know it's a bit vague, but you could get questions like this. You could say, but the average rainfall could tell you there's no water. When you interpret this question, all right, take this that there's water there all the time. All right? It doesn't decrease. I know we can debate that issue, but the similar type of question came out in the past and we took it as perennial river because there's water all the time. All right, so it's your perennial river, which is 1 mark. Let's look at the next question. Give evidence from your sketch to support your answer. And as shown to you, there's water in that river all the time. Okay, and that's a simple answer there. River stream has flowed throughout the year, judging from the average rainfall. We have average rainfall, there's water in that stream all the time. Let's look at 2.4. Explain 2 characteristics which indicate that the river is in the lower course. Can you see once again, learners, you worked out these answers by looking at the resource. You know already. If I look at this, let's look at it clearly here. Right, it's quite flat and the river is meandering quite a lot. The area around it is flat, which is your floodplain, and the river meandering a lot, which tells you it's in the lower course. Let's look at the answers. All right. The river has a wide floodplain. And see, learners, how nice the producer has been to me. He's writing it so I don't have to give you my terrible writing. All right. The river is meandering. And if you write those 2 points, you've got your 4 marks. Give 2 reasons. Let's look at this. Give 2 reasons why the river is likely to flood in summer. We've already made that note there when we looked at the sketches, learners. What did we notice? The larger volume of water, isn't it? There's a greater volume of water. All right. Also, the flat surfaces around it, okay, will allow this water to flood over and the water to flow over the surface very easily. But the main factor is the large volume of water. All right, let's look at the question or the answer, the memo itself. Flat land on the river banks. Not the perfect answer, eh? Not the perfect answer, but learners, you need to get 2 points. Okay? I would actually go, I put this, took it straight from the memo. I would like you to look at what is the most important point. The high volume of water available. Because this says summer, it can be in winter also. The land will still be flat. Now, how do you answer a question like this? It needed 4 points. You understand? You take the high volume of water first, talk about that it has a higher volume of water during summer, and then you take another one that will assist in the flooding, all right, in terms of the flat land, okay, all right. The water will spread far because now it's flat and the water will be able to flow over the land. So any other, the river meanders showing it's slowing down. That can happen in winter and in summer. In both sides it can happen. But you can use any other factor. But the high volume starts off first, and then any one of these factors which adds to the explanation, which gives you 2 marks. And I'm going to give you a little break now. Just go get that water and make sure it's only water, nothing else. And get back as soon as you can. Take that break. Welcome back, learners. I hope you just drank water and nothing else. I'm checking. All right, let's go to a different one now. Let's take a whole feature, a fluvial feature, and go into more detail into it. And I want to look at question 3 down here. Again, my rule, study the figure. Let's go through it. Refer to figure 3, which shows the development of a fluvial feature. And answer the questions that follow, obviously. Let's look at it. What do we have here? This one looks quite attractive, eh? All right, but it gives us some information, more information here. Number 1, we worked it out already, learners. This is your meander. You know it already at home. What we noticed, it's quite wide here. It's narrowing here. Can you see it? Okay. Now, let's look at the narrowing. Okay. We've got areas of deposition. Okay. And here we have area of erosion. So it's eroding here. And as it's eroding, can you see it? It's eroding into the land surface. So erosion seems to be narrowing the channel. Okay, according to our diagram. All right? We can even work out the flow of the river, learners. We don't have to give it to us. Because erosion is happening here, the river is flowing in this direction. Remember where the river hits that bank, that's where the erosion happens. Can you see it? Erosion happens. And deposition is happening on the other side. So we're getting the cut-off slope, off slope, and we're getting the slip-off slope. SOS, eh? Slip-off slope. So what? Look, just by that simple key, learners, we picked up so much about the diagrams. Eventually, we know what happens, eh? Because of this water coming and the erosion is going to cut right through. There's it cutting right through. And we get a piece that's separated. That's your oxbow lake, which can eventually become a scar, learners. Because you must remember, if the rainfall is limited at times, the river is not supplying this oxbow lake with water. It can either dry up or can become a scar. So, lots of information here. Let's get to the questions. Name the fluvial feature illustrated in the first 2 sketches. You've already worked that out. You understand? There must be a smile on your face. I know this already. All right. You know the fluvial feature is a meander. All right. There's your 1 mark for that. All right. Let's go to the next one. Reminds you a little bit like a crocodile, eh? Who's taking a bite. But it's still nevertheless very attractive. All right. Let's go to the next question. Name the process responsible for the narrowing of the meander. Now learners, I know some books tell you there's deposition and this. You understand? They're not incorrect. But you need to look at your diagram. It says name the process. And you've worked that out already. You can see erosion happening. So basically on this question, most of the answers are on the diagram. You just need to relate your content. So you know it's erosion. You've worked it out already. And your answer is erosion. And you got your 1 mark. But you didn't have to guess, learners. You don't have to guess. You can get the answers by looking at the resources. Let's look at question 3.3. Give reasons for the process of deposition taking place at point B. What's happening? Remember, the river is flowing and hitting here. Here it's taking the bend and it's slowing down. And because it's slowing down, it's depositing. All right? So B, deposition, because the water is flowing faster there and slower there. Okay. Let's look at the answer. Water moves slower, as we picked it up, and as I know you know the answers at all. All right. River loses energy. River load is thus deposited. But on the other side, all the action is happening. The erosion is happening. On this side, the deposition. Any 2 points? 2 marks, or 4 marks rather. Maths is getting a bit damaged here. Explain why feature D dries up. I predicted this one. I already gave you the answer. Why feature D dries up. You already worked it out. When you looked at the resource and you can visualize your information, whoa, the river has cut through. It's separated a piece. Is the river feeding that piece anymore? No. So the chances that this river can dry up because the main river, or this oxbow lake can dry up because the main river, it's not feeding it water. Okay? So let's look at the answer. Deposition occurs in the meander of the neck. We're explaining how the river gets separated. All right? It's cut off from the mainstream. It does not have supply of water from the mainstream. It can have supply if it rains, all right, or groundwater. But the mainstream, which is the main feeder of the water to this little piece, has been cut off. Therefore, there's chances of it drying out. Not necessarily it will dry off, learners. Depending on groundwater and rainfall, it could have water. But the chances are it can dry up. 3.5. Explain what promotes the formation of features B and D in the lower course of the river. Features B and D in the lower course of the river. What makes it happen there? What is so clear in that lower course? You understand? What makes the river bend? All right, you already know the answer out there. The gentle gradient, isn't it? Deposition happening because the energy of the river comes in. When that river comes in flood after a while, what is going to happen? It's going to flow straight. It's going to cut through the meanders. You've learned all this in class, learners. In fact, you've covered every little thing. Nothing can defeat you in class. What again I need to emphasize is all you need to do is take that information and apply it on the resources given to you. And geography comes so simple. Application, application. Even in your toilet, put a poster, must apply, so you don't forget it, eh? All right. Write that message everywhere. So let's look at it. The lower course of the river has a flat gradient. So it's going to start meandering. The velocity of the river decreases. It slows down. It's still flowing. Large volume of water. All right. To overcome the gentle gradient of the river starts to meander. Deposition takes place. All right. That's where your river starts to get into the Oxbow Lake stage. All right. River erodes the outer bank and not the inner bank. That's when you got in your cutoff slope and your slip off. Cut off with erosion, slip off with deposition. River erodes through the neck. Remember that? As it's happening, as it eroding through the neck of the meander. All right. Oxbow lakes remain behind and can dry up to form a meander scar. So any two, but I'm going to strongly suggest it must be one related to B and one related to D, because it asked B and D. In this case, the memo was marked that any two was given, but you must have relating to the Oxbow Lake and the meander. Let's go to another one. I'm going to give you another case study now. Let's look at that. Okay. Remember, the case study has to deal with a special place. Okay. The Breeder River catchment management. Now watch this one. I'm going to show you how many answers you can actually get from the case study. Okay. Let's see it. I've given you a lovely picture here of the Breeder River. All right. And the catchment area and the river system. Let's look at the article. Catchment management aims to effectively and efficiently manage naturally occurring water in a catchment area. Sort of a definition, eh? Or telling you what catchment. If that comes out, what? Straight from here onto your paper. Let's look at the next one. The Breeder River water management area is situated in the southwest corner of South Africa, giving you a specific location. All right. Maybe relevance, maybe not, but it's telling you it's a case study, we're dealing with it. Its main elements of vision are the inclusion and participation of all stakeholders. Brilliant, eh? You're getting everybody to take part because everybody is in it. It becomes easier to handle or to manage, or the projects is more successful. When you leave people out, people don't want to agree in the end. They say, but we haven't been consulted. Competing environmental and human priorities, huge debate, eh? Learners. On one hand, it's not always wants that make people develop, it's needs. You need to look after the environment on one hand. On the other hand, you say, but I need to build houses for people. I need to build schools. So you need to have a balance between the two, eh? Ensuring the availability of good quality water. You need to ensure that, because if you're developing on one hand, you need to save the environment, because if you just develop, it'll come back to bite man, because you get poor quality water, which could lead a lot of problems for man. And the responsibility to eradicate poverty, eh? Lots of issues here. Because on one hand, we're saying preserve the environment. On the other hand, we're also saying we need to eradicate poverty. On the other hand, we also say by supplying water, good water, we're going to help eradicate poverty, because farmers will get water, people will get water, which is a basic need. Let's look at what the aims of the project is to ensure quality water for all people and the environment. Very important that we must have water for all people and not select few. And when we mean quality, we mean proper piped water, good healthy water to drink. Ensure good administration and registration and licensing. All right. Also inspire change in attitudes towards the environment, because the good administration and registration and licensing will also make sure, you understand, that no corruption is taking place and people are disadvantaged. Inspire the attitudes towards the environment, make them see the reasons for why we need to preserve the environment. All right. And I think we've left out one here, and the gremlins got in and grabbed it. All right, look at the economic significance of also of the area. You understand? Also the balance between the environment. These are the other challenges or the aims of the project that were put in. All right, and also sustainable development in terms of economic development. Because what do you need? You need to also develop in terms of people's quality of life improving, but you must make it sustainable so as you're not damaging the environment, that there's more for it in the future. Okay. Let's go to the next one. Number 1, define a catchment area. You're taking it, a catchment area is an area that collects the rainwater. You know that already. All right, an area that collects the rainwater. All right, or catches the rainfall. That's your 1 mark. And what is catchment management? Now I'm going to show you this, learners. Basically, you took this straight from the paragraph. You got a mark for nothing if you read properly. I'm going to go back to the paragraph. All right, there it is right here. Okay, right here. There you've taken it from there and you've placed it in, and you can do so. And that's 1 mark. You've got straight from there. All right, catchment management, which is your 1 mark. State 2 ways in which man is having a negative impact. Negative. Very specific. Negative impact. Now, you've studied that in your work before. All right. You know it. It's actually lower order to a certain extent, although it's scaffolding. You know deforestation, overgrazing, all right, urban development. There's so many factors you can talk about. You need to state any 2 and just state them, all right? I'm going to go through my answers here. Overgrazing, there we are, my favorite ones. Deforestation, urban development, anything that man is negatively impacting on the environment. In fact, man negatively impacts all the time, sometime out of need, sometime out of want. Let's look at the next question. State 4 aims of the Breeder River. State 4 aims of the Breeder River catchment management. Although the question looks so sort of analytical, etc., and you're stating, but basically this again is taken straight from the passage. I've purposely put in a question like this and designed a question like this to show you that we can, maybe you won't get so many, but you can get stuff, and reading the case studies are very, very important. Look at this here, learners. All your answers, including the one that the gremlins took out here, where we talk about sustainable development, etc. All is here. All you have to do is take it straight from there, put it onto your paper, and you got your 4 marks. Beautiful, eh? Right. Can you see it? Here we are. Straight. We're looking at ensure quality of water, straight from the paragraph. Ensure good administration, straight from the paragraph. Inspire attitudes, and there's the gremlin one that disappeared. Promote economic growth in a sustainable way. 4 marks for reading the passage and or the case study and interpreting it. All right, can you see I'm just swinging away to tell you how easy it is. Okay, let's look at question 4.4. Explain. Now look at this one, little learners. Okay, explain the benefits of these aims to man and or the environment. Watch this question, and or. So it can be, you can explain man and the environment, or man or the environment. Doesn't matter. We want this. So we're taking it to a higher level now. We say they put this in place. This is not in the article. This is where you relate your work that you've studied and the ways that you applied it to the aims. But you got a big tip here already. Take each aim and look at it and work out what is it doing. Let me show you this. All right, on question 4.4, and I'll show you. Right, okay. Ensure quality of water for all people in order to address the development needs of people to contribute to the eradication of poverty. So I took the first one. You understand? I took 2 important things. They ensure quality of water for what? So that the development needs of everybody, for them to order to develop and improve the quality of life, everybody should be getting water. So that's why he's saying the quality of water to all people, and there's your answer here. Can you see it? So that we eradicate poverty. Let's take the next aim. Good administration and registration and licensing in order to show fair, equitable, well-controlled water while maintaining the integrity of the natural resource. Remember, corrupt administration, we're not going to get fair, equitable, well-controlled water allocation, and also the integrity of the natural resource. People could abuse it. You must know people want to make money. They could do anything and damage catchment management. So can you see again? There's the aim, there's the answer. Let's take the next one. Inspire change and attitudes. That was the aim in the environment. There's the reason now, what it will do, in order to manage the ecosystem in a sustainable manner. All right, you need to change people's attitudes, because it then will be, what do I mean by sustainable manner? If you maybe have catchment management, but if you don't change the attitudes of people and they don't see the relevance of catchment management, they're going to enjoy the surplus and maybe overuse the water supply and don't bother to conserve the area. But if you get attitudes that are positive, and you can see I feel very strongly about this, because we need to conserve our environment. And then if you get attitudes correct, people will all play their part. Even in their yards, they'll be wondering how they water and what they do, the type of vegetation they plant, which will then create more sustainable. The last one, okay, promote economic development in order to allow development to occur, but also consider the natural environment and the catchment areas. So we're saying here, the one that the Gremlins took out was on economic and sustainable. So we should allow, if we got it a little chopped here, maybe I'll take out that and put it together. So we should allow development to occur. But in order for sustainability, while we're developing, we need to say, let's look after the environment. What impact are we having on the environment? Are we damaging it? Can we slow down on this? Can we recycle this? Can we do this so that we keep a balance between economic development and the catchment management, so that we have this resource for future use to man? Okay, and that's some of the questions, learners. Can you see how many answers have we got there and how interesting? Geography is the best. All right, take that glass of water again and come back soon. Welcome back, learners. I'm really excited to go to the next question, so I'm not going to waste time. I'm going to get right into it. All right, I'm going to show you, although this is similar to the question that we did earlier on, but it's nice to also show you how can the similar stuff be answered with a different type of resource. All right, the earlier one we looked at a cross profile. Now we're going to look at a longitudinal profile. So let's get going. Refer to figure 5. Based on a drainage basin. So it's telling you, immediately let's look at it. There is my drainage basin. All right, and its longitudinal profile. Because this can become a bit confusing, learners. So I needed to look at the instruction, and the examiner has given me a little more so that I could interpret the diagram. I'll say, but where is my longitudinal profile? Whoa, there it is. Can you see it? It's here, upper course, middle course, lower course. So I found that out. Let me see anything else here. I can see this is the mouth. There's a sea here, and there's a little fish here. All right, okay, so that is the mouth. Whoa, that fish makes me hungry. All right, let's look at what else the examiner is pointing. He's pointing to B. What is that? He's pointing to this little stream pattern here. All right, or drainage pattern. All right, that looks clearly dendritic, eh? Dendritic. So I picked up quite a bit of information. What else can I pick up here? Oh, let me look at this it's quite smooth, this longitudinal profile, eh? There's no obstructions on it, learners. Did you notice that? So we can look at this as being graded profile. Okay, graded profile. All right. And learners, just one thing I know, maybe not related to the question. Remember very clearly, you guys make a lot of mistakes when it comes to this one. Stream channel pattern is your meander, your oxbow lake. Stream pattern is your dendritic, trellis, etc. So stream pattern is the same as drainage pattern. Stream channel pattern is your meander. I thought I'll just remind you, because that seems to be a common error also, eh? But let's get on to the questions. I think we've covered the diagram. There we are on that scaffolding style again, eh? Explain the term drainage basin. Again, you know it's an area which the stream, the main river and the tributaries drain. Okay? Let's look at it down here. An area drained by a river and its tributaries. Full explanation, eh? Not an area drained, but an area drained by a river and its tributaries. You've got your mark. Let's look at the next one. Explain the term longitudinal profile. The examiner is setting you up nicely. Eh? It's building you up to sort of make you focus on these two issues because he's going to test you or she's going to test you on that. All right, so let's look at the next thing you know already. What's a longitudinal profile? It's a side view of the river from the source to the mouth, a side view of the river from the source to the mouth, and you've got your marks. And these are simple marks which you must not get wrong because you're going to get the rest wrong. Let's look at the next question. What evidence suggests that the longitudinal profile is a graded profile? Immediately it's your concepts again. Remember, we're emphasizing graded profile. We can't go generally. A graded profile as this, an ungraded profile as that. The examiner is saying what evidence means that you have to examine the source material. Learners, this is also a very, very common error. People get too answer happy and they just jump and just give answers without referring to it again. Now, if we look at this, clearly we've identified it already, learners, that this is showing you a smooth concave profile. There are no obstructions in this, no rapids, no waterfalls. So it's definitely a graded profile, all right, because it's a smooth concave profile with no obstructions. All right, let's look at it. It's a smooth concave profile with no obstructions. I would like this to be 2. It can come out for 1. It can come out for 2 because I believe this is more giving evidence that suggests that this is a concave or a graded profile with no temporary base levels. All right, let's look at the next one. 5.4. Name and describe the underlying rock structure associated with stream pattern B. Learners, I'm going to put a few lines here. Stream channel pattern is not written. This is stream pattern, also known as drainage pattern. Pick that up, write it in your notebooks now so that you don't forget, because you tend to make that mistake and lose marks although you work so hard. So name and describe. There's 2 issues here, learners, naming and describing. But some of you don't. Learners, do little highlighters. Keep highlighting each time you're doing this so you know there's 2 issues that you need to handle here with this question. So first of all, I have to name. Let me go back. I've got that already. It's a dendritic pattern. So I write it down. Then it says, describe the underlying rock structure. People jump branches of a tree because you don't read. You just read name and describe. It's the underlying rock structure. And then people write just sedimentary rock. So what? Remember, sedimentary rock can be on the surface. What's underneath? And the main thing about a dendritic pattern is sedimentary or horizontal sedimentary rocks with uniform resistance. Okay? Horizontal sedimentary rock with uniform resistance. If you wrote igneous, you don't have to write uniform because igneous rocks is hard throughout. So it's uniform already. Okay, let's look at this. I know I'm emphasizing this, but this is a common error we see year in and year out when we marking the papers. So let's look at it down here. All right, horizontal sedimentary rocks. Okay, the little stream with the stream pattern, it's horizontal sedimentary rocks. Sorry, my mistake early on. It said name and describe the underlying rock structure, not the stream pattern. Can you see how easily we can get confused? That even I can. So the first one was horizontal sedimentary rocks, and the underlying rock structure is massive igneous rocks or rocks with uniform structure. So identifying the underlying rock structure, or the name is the horizontal sedimentary or igneous, and then the underlying rock structure is rocks with uniform resistance. That would give you your 1 mark and your 2 marks. 1 mark there and 2 marks here. Okay? Let's look at the next one. Give a reason. Give a reason for why the river follows a meandering path in the middle course. Now what the examiner is doing, is relating this issue or that piece of the diagram to this piece. We don't have to sort of start thinking about what we studied. We can see here it is steep. It is steep. You understand? So the river is going to flow faster. Look at what's happening here, guys. It's getting gentle. So what's happening there? The speed of the river is slowing down. So it's starting to meander. So once again, we're applying our knowledge and using the diagram to answer this. Can you see how important it is to apply each time you learn? So it's getting gentle here, and therefore it's starting to meander. Okay, let's look at the answer. Right, the gradient is less steep. All right, let me get my pen back. It flows on flatter land, so deposition starts. The gradient causes the river to slow down. All right, therefore it starts to meander. It has an increase in volume, and remember, it's carrying a greater volume, a greater load, and it has less energy, so it starts to meander. So any one of these reasons, all right, the best reason here is that the gradient is less steep. Okay, so therefore it starts losing energy and it starts to meander. But we worked it out using the diagram also. Let's look at this 8-mark question here. All right, fluvial landforms in the upper and lower course of the river differ greatly. Make sense of that? All right, there's different types of fluvial landforms in the upper course and the lower. Not that you won't get certain things. You could get a waterfall in the lower course, but generally speaking, there's different types. There's waterfalls, there's rapids, and in the lower course, there's braided streams, there's meanders, there's floodplains. All right, so already you start picturing that there's different. Write a paragraph in which you explain how different stream flow, that shows this difference in the stream flow. Again, you're thinking, whoa, upper course, faster stream flow. All right? Lower course, stream flow is slower. So faster, that's why you're getting your rapids, your waterfalls flowing. It's getting vertical erosion. You understand? There. Slower course, slow flow, more deposition. Think about your braided streams, floodplains, meanders. All right? Erosion processes. That's another point. So there's various issues, quite a complex one, this. Erosion also. There's more erosion on the upper course. You understand? It's cutting in, and it's cutting those deep valleys, etc., which is creating your waterfalls. All right. Whereas there's less erosion, more lateral erosion, and not much in the lower course, which then is creating more deposition. All right. Are responsible for the development of different landforms in the upper and lower. So we know there's different landforms, and now we know, and the question is asking us, tell us how stream flow and erosion, you understand, is responsible for these different landforms in the upper and lower. So there's few things here. We have to talk about the landform, we talk about how stream flow and how erosion causes the landforms. But we already worked out many of those answers already. All right, let me see here. I must get it back to my, let's look at it. Upper course, can you see? We took the flow, turbulent flow, not necessarily, but on many occasions. All right, rough stream pattern, vertical erosion, can you see? So we have down cutting. It forms steep slopes, all right, or V-shaped valleys. You know these answers already, but I discussed the upper slope. What forms? Rapids. waterfalls result from uneven riverbed because the river is ungraded. This thing is cutting down to vertical erosion, therefore it's ungraded. It has base levels. So therefore things like waterfalls and rapids will form. All right, headward erosion, therefore stream gets longer at that point. All right, therefore also by headward erosion could be uneven and also create temporary base levels. So I got here, I've covered, I can take one of these points, you understand, and these features, okay, and I've got my 4 marks. But remember, I also have to do the lower course, and I have to show the differentiation. So here I could talk about laminar flow, all right, results in a smooth river channel. Remember, this is generalizing, not always the case. We get lateral erosion, all right, it forms wider valleys, okay. What does it result in? All right, meanders and oxbow lakes. Can you see the difference? So I could take these features here showing me the process of erosion and flow, okay, and I could talk about the features, and that will give me my 4 marks, which gave me my 8 marks, but a complex one. There's various issues that if I leave out one issue, I'm going to lose 2 marks. Okay, let's go to the next one. River capture. All right, another concept which people find difficult, but if you interpret your diagrams, you have no problems again. Let's look at this. Refer to the process of river capture that's shown here. It's telling you this in figure 6. All right, and obviously answer the questions that follow. Let's look at this. What's happening with all the questions? Okay. Now be careful. On this one, this river looks quite big, eh? Quite big. But look at both diagrams in relation to one another. What is happening here? This river has come across the watershed. You know that in river capture, there's a watershed. This river has come across for various reasons. It could be greater volume of water. It could be steeper gradient in which it was flowing. All right, it could be softer rock here, so therefore it eroded through via backward or headward erosion. And this river has captured the headwaters of river B. Okay, so this river A has captured the headwaters of river B. Can you see it? Now what's happening? Let's look at it. May look a bit different from your notes. This area is becoming dry, isn't it? So that's your dry gap or your wind gap. This river is becoming smaller for its river channel. That is your misfit stream. This river has captured the water. So that is your captor stream. This piece has been taken away. That is your captured stream. There's cultivated land here. One more thing you'll notice. River capture has happened. This river is there. Look here. There's cultivated land. Do you see the cultivated land there? No. That means the river has dried. Farming is gone. And you see how much information we picked up, learners? Lots of information. So let's look at it. Name the type of erosion that has taken place in this area. All right? You know when one river captures the headwaters of another river. Let's go through that. This is a simple one. So the type of erosion that happens when one river captures the headwaters of another, it has to erode through the watershed. And because it's eroding through the watershed, it's known as headward because it's eroding towards the source, also known as backward erosion. As the source is there, if I even drew this, you understand, you can see it happening here. There's this river flowing here, and if it's eroding through the watershed, it's headward or backward erosion. And that's your 1 mark. Learners, use your resources. Well, I hope I've given you further insight into geomorphology. Please, there's your mindset website where I've got more questions for you besides these ones. Do go through it. There's different types of questions there also. It will benefit you. All the best. Go out there. No more 80%, but 95%. Sharp, sharp. So I've got quite a few. Where does this fit in, the braided streams? I picked up already. My braided streams fit in the lower course. Okay, because there's a lot of deposition. Okay, let's look at the questions now. Identify stage A, B, and C. Learners, you don't even have to look anymore. You know the answers already because you interpreted the diagram. And you know A, lower, B, middle, C, A, higher. I'm getting a bit old here. Or upper, B, middle, C, lower. I've identified the things already. Can you see it? Each one 1 mark each. Upper, middle, lower. Just one little warning, learners. Some of you get too trigger or pen happy and you just write upper, middle, lower. Please, one important thing, and learners lose marks, please write the letter next to the course of the river, and that will give you your 3 marks. Okay, let's go on. Draw a rough cross section for each of the stages. Again, can you see that scaffolding, learners? What actually happens here is, if you don't interpret the first question, you're going to mess up the other questions. Now, you've already learned. Hello, learners. Welcome to another session of geography, and I hope you're ready for it. It's geomorphology. Some of you don't like it, but it's a section where you can score a lot of marks. But let's not waste time. Let's get on with it. All right? So let's look at what's the main things in geomorphology again. All right? You very quickly, you're going to look at all the concepts related to a drainage basin. Know those concepts. Otherwise, you won't be able to apply them. Then you're going to look at various other issues on fluvial, river profile, river grading, river rejuvenation. All right? These things are simple. Identifying, describing fluvial landforms, river capture, superimposed and antecedent streams, and catchment and river management. Looks new, but it has been there before. We have covered it before, but I'm sure you know all this work now. All right, so let's get down to the questions. That's the most exciting thing. Okay? And again, as I always say, please, learners, do not look at the questions yet. Look at the resource. I know you get fed up of me saying that. All right, let's look at what this resource gives us here. Okay, it gives us a little profile looking at the river. So I can see number 1, precipitation. Okay, I can see here the rainfall. I can see this is a high-lying region, so that is my source. Then what is saying A, B, C, D? I can see this is showing me the upper course of the river, the upper course. Here, very quickly I can see what's happening. Flowing quite straight here, steep gradient. Can you see I'm building it up? If I know my information, I'm relating it to here. Then I'm noticing what's happening down here. All right? I'm noticing as it's moving, it's starting to wind. Not so heavily, but it's starting to wind. It's starting to meander. So B could be my middle course of the river. Here I'm noticing very quickly, upper course, vertical erosion. It's starting to form the river, isn't it? So here in the upper course, steep-sided valleys, narrow, because it's starting to form. What happens in the middle course? It's now we have vertical still dominating, but we also have lateral. So here it was 1. Here we have this happening. Vertical and lateral, because it's carrying its load, it's bumping. The material is there. So what's happening? Maybe I should draw this a little wider. Maybe I could draw it like that. The river is getting wider. And now here what happens? Carrying a huge load. All right. But it's flat, less erosion, okay, more deposition. So what happens in this one? The valley becomes wide because we basically have some lateral erosion and more deposition. So we worked that out, learners. We knew it already, and I know at home you're saying, Dave, you're boring me. I know these answers already. All right? There we have it, A, B, C. All right, getting wider and wider. Identify feature D. We've already identified it. We know it's noticing a massive winding, and the gradient is quite flat here. Eh? It's flat. So what am I looking at here? My lower course, the flat plane, the braided streams, the sand islands forming in there. So I've picked up quite a bit down here. Obviously, there's a few more things. This is my watershed. You know, it's a high-lying area separating two streams. Okay, not much else is pointed, but I'll be able to determine like my interfluve, my confluence. I'm not going to worry so much because the examiner has highlighted certain issues down here. Let me look at what else has been given. What is that? D. I could see sand islands. I could see streams flowing in between the sand islands, and obviously they're going to join again and they're coming in here. So that I immediately pick up is my braided streams. Braided streams. Can you see? Geography keeps up with style. Even geography has braids, like you guys out there. Okay.